Good morning, guys. This is Hemant from Prwatech. Welcome to today's session. Today's session is totally about the pig. Pig is basically is a pig-related tool that is developed for the big data or Hadoop ecosystem. So there is a little document. We'll go through that. So in pig, this normal command to start pig, that how we can start the pig on our terminal. Suppose I had a Cloudera, and in Cloudera how we can start. So this simple command, you can see here, there's two command for that. Pig-x mapreduce, pig-x local. Pig-x mapreduce is for the mapreduce that we are using Hadoop ecosystem cluster, and we want to process the data onto pig, and in local mode there is simple command for that, pig-x local. So in mapreduce we can also use, instead of pig-x mapreduce, we can use only pig. That would be the same name. So let us start pig. So now you can show grunt mode. You can see the grunt mode. Now there are several operators we will discuss about this. So first is load operator. In load operator, this if we are considering this syntax, we can easily understand through this syntax. In this syntax, there is relation name. The relation name can be A, B, C, or my name is any data name. Suppose you are loading the customer file, you can give this relation name customer. After that, you can load the file. Load. Now we are using load operator in this, so this load operator will use in this. This is not case sensitive. You can write into small or capital. There is no issue with that. So relation name equal to load input path file. Where is input? Your cluster file location. Suppose you want to process a employee file, and there is located on your cluster, so you can give this path, import file path, using function. Which function you are currently using? Suppose there is by default function in this pig, there is pig storage. These various functions are there: pig storage, text loader, bin storage, json loader, xml loader, through using the piggy bank.jar file. So that will be the further part. First we have to write this, that we have to learn this, like how we can load the simply data into HDFS. Now there is, you got the m file, this m.txt, you got on cluster. In this machine I got this m file. You can see basically the ID, name, and salary. These are the three parts here. First I moved this file on the cluster. The cluster you can check in pig, you can check directly amp.txt. So I loaded. You can check through this command fs-ls, because when we are using on cluster, so we have to write on the terminal Hadoop fs-ls, but you are using the Hadoop tool, so you can write here fs-ls, you can get the whole file on the cluster. So I already stored these files that we will use in the PDF customer orders. Okay, now we have to load the data. Now how we can, first relation name, and it can be anything, employee, whatever you want to give. It's like a declaration. So amp equal to load. Now earlier I mentioned there's no case sensitive in this, so you can write anything. But there is one thing, function, there is, you have to write in this syntax, because without this syntax it would not accept. So for only the function you have to use this. We are using this. Now we have to define the schema. We earlier see in the file there is id, name and salary. So for that we have to define the schema on the data that we are loading this file m.txt. Now we have to define the schema on this, that which data will going where. Suppose if we can see in pdf that adds id, name, salary. This by default is, instead of string, char array would be the data type. So let's go into this. Now this data is storing using pig storage as which structure, as id as an int and name as char array and salary again write the char array and semicolon. Now how we can see the data? Is it store or not? Just write the command for that, dump. Through dump we can see the data. Dump emp, dump and relation name. What relation name you gave? Now MapReduce is running. You can see your data into pig. Now pig is a kind of ETL tool, like extract, transformation, load. We will extract the data into this, transform the data and load the data again into HDFS. There is the, it's kind of filtering tool you can say, because suppose there is the big data is all about the unstructured data, that how we can process the unstructured, semi-structured data. So that's why pig is using. So now store operator. What is store operator? Now store operator, the simple thing, we load the data through the HDFS into pig. Now store is all about the pig to HDFS. That how we can store the data through, we process some data. Suppose we load this data and we get the operation, some operation onto this, like filter operations and join operations. After that we find out the new output. After output we have to store the data somewhere, so that will location will be HDFS. So for that we have to store this, we have to use this command, store relation name into required directory path. The same thing but instead of local load. So for that, suppose I processed the file and now I can see that file this. Now I have to again this file load into another file into HDFS. So we can see store the relation name into path, the new path amp new directory. You can see the output using pig storage. Now if you want to see the function, suppose I'm using store amp into, what is our path? Path is HDFS colon HDFS colon double slash localhost slash. Suppose we want to store into amp new this output using the same function pig storage. Now MapReduce will run 0%, 50%. Now you can see output successfully stored 6 stories that we input in this file, successfully read 6 records from this file. Now we are reside this file into this directory and new directory. You can see using here fs-ls amp new. This in amp new there is output file part, and if you will get this file you will get the same output onto cluster. This is the same output, you will get this. Now we know two commands: load, store, two operation. Third is dump operator. We have already seen this, that through using dump we can see the data, that what is stored in this variable. Now the describe operator. In describe, when we will use this describe operator, we can see the schema that what we defined. Suppose I don't know the schema of amp, so you write the command simple for that, describe amp. Now you can get the schema of this: id, name and salary. These three attributes we are defined here in amp. It's like SQL. In SQL we are defining the table is same like this. So after describe operator, the explain operator. When you will use explain operator, you can see there is what is the scope of this, which kind of data type you are using. Int, that is casted by the character array. Int, the scope, particular scope, there is default simple for that. So after this, just go on the illustrate operator. Illustrate operation, it will give you the step-by-step execution of sequence of statement. Suppose you are doing the illustrate amp file. Illustrate amp. You will get this 102 Sangeeta 3000 like this. Total input path 1. It's like a table, so you'll get this data like this. Now what is group operator? Group operator is basically used to group the data. Suppose you get the two files, and no, you are get the file and you have to file group by name, group by id. You can group a particular data by anything, like you have the some attributes: id, age, name, salary, anything in employee. And now you want to group the data according to name. Suppose there is more names, the simple, suppose you have this more than two names, similars name. I'm talking about the similars name. There is more than two similars name are there in the table. Now when you will group, you can see the name will group by the name. Suppose you are taking the action group by name. Now in this, suppose I'm grouping by the salary employee. So suppose there is six employee in this, and there's two employee having the same salary 30,000 30,000. They will group by together. So let's see the thing how we can group this. Now we are creating new relations. Amp group equal to group. Now we are using the old relations. That in old relations we are using group by their names or salary. Suppose we are doing by the salary. Now when we will dump this, you can see the particular output. The salary, the data will group by salary. If there is common salary, the two employee having the same salary, they will group by this salary, particular salary. So there is having the different salaries, so they are grouped by the individuals. Okay, so there is different salary are there. There is different name, different ID. Suppose you want to group by the two column, sorry, two column ID and name. You can group. You group by the whole thing. You can group. There's simple commands for that. Group employee by the name salary, group employee by the ID names, group employee by the whole attributes. You can do easily. Now join operators. There is a simple operators in Pig. So now we are studying about the join operator. In join operator there is three kind of join operators are there: self join, inner join, outer join. In outer join we will read the three kind of joins are there: left outer, right outer and full outer. So first we will discuss about the self join. So in self join we will join the table with it itself. Suppose there is two relations and they're having the same table. Suppose I'm using the first customer table. Suppose I load the data customers.txt into customers, and the same data and the same schema I'm using the another relation customers one. Let's do, we have the already store into HDFS customer data, you can see. So we will use this data. There is a command simple, you can put the data into HDFS Hadoop fs hyphen put and then file name and then slash on the cluster. So now we are loading into customers. You can do any customer equal to load customer, location is slash customers.txt. using Pig storage. I'm using comma in this. Why? Because data is separated by comma. So that's why I'm using comma in this. If data is separated by the tab demolition, so you have to space. You have to give here space. Now the schema is what is the schema of this data? This schema ID, name, age, address, salary. So ID as an int, name as an char array. Earlier I mentioned. Now what was the third? That was the as again you can define the int and address and salary. Address you can say char array and salary. You can give salary int or char array, whatever you want to give you can give. Suppose I'm giving here char array. When you will dump, you will see the data loaded into Pig, the relation's name. Now you can see here the data, particular data. Now there is Priya, Madhu, Nath, Riza, Rahul, Kushagra, Tanya. This different data using ID, name, age, address, salary. So this is the basic data. Now suppose in this second data orders we will define after some time. So in this, suppose you are taking this, it is used join a table with itself, self join operator. Suppose relation third name is join relation 1 by key, relation name by key. Suppose you are using the two tables same, again I mentioned save two table file customer 1 and customer 2. Suppose I'm using this data, the same command I'm using the customer 1. It's got some error. Suppose it will give again error. Suppose I'm using customer 1. Same file, customers.txt, using pick store res, the same function. The schema will be same, but relation name is changed, so it will store age is int, address is char array, salary is char array. Now you can dump this data, customer 1. When you will see this data, there will be the same data into two files, two relations, customer and customer 1. Now you are joining these two relations thus having the same data into customer 2. Suppose the same data you are having here. Now in self join operations there is simple command that relation name third. Suppose we are using by the key. Now we can join this by the ID. Suppose customer 2 relation having join customer by ID and customer one by ID. So you can see the file. Now you can see the file. So now we having these tables we stored by the ID, the same data. Now you can see dump this relation customer 2. You will see the data. You can see the data group by ID into customer third. Now the same data, Priya ID name is same 1, 32 is, but grouped by one, group by ID. So that is the self join operation. Now in inner join operation, there is simple matching that both relations. Suppose we having in order table. First load the order table into orders. So I earlier mentioned there is I stored O's on the HDFS, so you can see orders is also there. First store the important files that you will need into Pig already stored into HDFS, because for the certain period you will not get the command again and again. So first store the data into HDFS, then use one by one. Suppose in order I'm loading orders dot txt using Pig storage. Now what is schema for that? Let's have a look. Schema for that is order ID that we will see here, right here, order ID as int, and date as a character array, customer ID amount, customer ID and amount. Amount you can give char array if you are not know the data type. And what is it there? Basically, in order you are granting the column define this order in order we define this file, and then using Pig storage as yd as a int, date as a character array, customer ID as a int, amount as a char array. So there may be some error, so that's why it's getting the error. Dotted line, maybe you can check out here. So orders.txt using this, the same command we are using here. So why is getting the error? Let's have. So we are loading the data, and now you can see using this data we are loading in orders using the same command, because there is maybe some issues earlier. Now we load the data. Now in inner join, to join according their matchings, suppose we have the tuples in customers. In customers we have tuples 6. In customer we have 6 tuples, but 7 tuple, but in order we have only 4. So how we can manage through the id? So when we will do the inner join, it will show only the 4 because these are 4 and there will be tag the 4 join. So for inner join there is simple command is relation name third and join first by this and second by this. Suppose if we describe customer first and describe orders. Now we can get the scenario of this data type id. This, have you noticed there is one thing in customer and order, this same thing is there is salary. So according to their salary we can join. Suppose when you will read here join customer by id and orders by customer id, because in customer id and the main in customer relation id is same, so it is joining through the id. We can also join, suppose we are joining these two, customer and order, just make the simple relation. Now join customer by id. Okay, this id, we having this id, in order we having this customer id. Okay, now this is by the id and orders relation by customer id. You can see in orders the customer id, customer id. So it will join. When you will dump this, you will get the same scenario. The scenario of inner join, the 4 corresponding table from the both tables, you will get the join operation, the whole information through both tables. Now you can see id2 in order id2. So there is the little concept here, 3 id custom in customer id3 in order customer id3. So like this we manage the data. So now this one is left, that is outer join. Now in outer join there is simple concept. First is left outer join. It will show the old details of left table. Suppose there is left table is customer. Customer. In customer we are using ID. Left outer. The simple text we have to use in this. In order by the customer ID. Now we are using the same thing, join customer by the ID and order by the customer ID, but we are creating here the left outer. So through left outer it will get the different output. So let's see, suppose you are again joining, just make the one relation name and here now customer ID left outer. So this syntax you have to use. Now it will show into this customer order 1 because this is a different relation. Now you can get the scenario of this, that the different output in left outer. Now you can see the output. The left table is all, but this join operation which is performed by these two, the same thing. Okay, there is left and right is when you will put the right instead of left outer, it's the same thing. It will show about the order customers. So in full operation, when you will do the full operation, it will give the different outputs. Let's see, suppose you are using here full outer and relation name should change. Now we are using the 2. Now dump this customer order 2. Now when we will dump in the corresponding that having the no left table, suppose in left table there is some values that having the no values from the second table, they will be the none like or null like this. You can check out the output. The same output you will see like this. There is no output, there is define the comma, that there is null output. Okay, so we perform this. Now union operator, how we can use the union operator. So let's see, we are defined amp table and we are union amp1 and amp2. It will merge the data of two relation. Suppose we are having the same table amp, dump amp. Let's see the output of amp table. Now we have the amp. Now just make a amp1 file. The same scenario with this load m.txt using pig storage. The same function we will use, but data type would be id as int, name as a char array, and salary as a char array. Now store this. Now you can merge these two files, use union. Suppose we want to these file merge into 1-2 relation. We are merge amp and amp1 using union. Suppose union amp1 and amp2. Union now when you will dump this amp prayer, you will get the data. We are having the same data, so it will merge. Four six 1346. So how we can manage the, suppose why we are using here, suppose the schema is same but the value is different. We stored 1 to 6 value into first and after that 7 to 12 value into second value. Now we can use to merge, we can use here union operator. So that's why we are using the union operator. After union, there is similarly split. We can split the one relation into two relations according to conditions. So now filter. The filter concept is same. We can filter the data using, suppose we want to just only the person having the id 2, we just put the data into filter data. So we are filtering the data using this. We can use this simple command, filter data equal to filter amp, and suppose filter amp by id. We are using filter by id is equal to 2. Now we'll get the value. We have to mention filter data because there is no id, there is id 102. So there is not 1 or 2. So now we are using this 102, so it will show the output only Sangeeta 30,000. So just less than this data, filter data 1. Now you can see the output. We process all the data. Now this several operator we will use in distinct operator to remove the duplicacy or duplicate. Suppose we having the same name, same id name, or same all things, so we can use this command. Suppose earlier I joined m12 or filter data. So I mentioned in earlier, suppose here I union two operation, there is simple name. Now we can, this is the m12 data, remember. So this m12 data we can distinct into new files. Suppose amp122, just give the relation and just use the operation distinct. Now using this distinct this, we will remove the duplication. Now done this, you will find again the single value because we merged two values. Now you will find again the same values, that is having the same data and same operations. So it will remove the duplication. Now you can see again there is single data. We having the same data two times, but when we use the distinct command, we filter out this data. Now the same operation for each and limit. For each, that suppose you want to generate the particular tuple from the ID. Suppose I'm using the amp and I want to generate only ID and name instead of ID's name, salary and all things. ID, name, salary, all things. Now using this we can use, suppose I'm making here the same concept. Okay, now using this same concept, suppose my system getting, suppose for each data I'm making the new relation. Now in for each data I'm using for each function, for each operation operator. Now for each m data generate only id name. For each m generate only, suppose I want to generate name and salary, so we can dump, we can see this data using dump. So using dump we can see this data. Now the data which filtered by the name and salary. So we have the same data but name and salary which we use these functions. So now there is last function is limit, that on which limit we want to data. Suppose we want only fourth row, so we can use here 4. We want to face the 5 row instead of 4, so we can use 5 instead of that. So today we have completed pig, and if you get the more queries, you can connect with us on the support@prwa.in. You can mail us about your problems, you will see, and you can ping us on to Prwatech, a Skype group we having the as well as a Skype group. You can see here, and you can put here any query. You can contact on this number. Suppose I am having some queries, so I can dial this number, or I can put my queries on this Prwatech. Okay, so hope you guys enjoy this session, and goodbye. We'll meet in the next session.